Okay. Question 1, estimate the condensation temperature of argon on Titan surface. So argon is the triangles, which is the middle one over here. So what is shown to us is the wave pressure curves, meaning liquid gas boundary. Therefore, at 1.4 bar, which is the surface pressure of Titan, the 1.4 bar line crosses the argon wave pressure curves around this value over here, meaning you have a vapor pressure close to let's say 182.5, 183, 184. So closest one is 183. I'm gonna go with that. That's the answer. All right, now question 2. In which substance do particles have the highest average kinetic energy? Okay. So average kinetic energy depends on the temperature. They all are at the same temperature of minus 185 degrees Celsius. Therefore, they should all have the same average kinetic energy. Therefore, the correct option is option D again over here. Right. Rank the boiling points of these substances at 1.5 bar. Okay. So it doesn't matter actually what the pressure is. So at any given temperature, let's say that it's 2. Okay. So here's the 2. Okay. So, now when it comes to nitrogen, it's going to reach that around 190. When it comes to argon, it's going to reach 2 bar external pressure around this value. And then when it comes to oxygen, it's going to reach around this value. Okay, so you see that oxygen has the highest boiling point, and then argon, and then nitrogen has the lowest boiling point. Okay, so the correct answer must be option B then. Yeah, it is same at 1.5 bar as well. 1.5 bar is over here. Same idea. All right, anyway, let's move on to question 4. In which substance do particles have the highest average speed at minus 185 degrees Celsius and 1.5 bar? Okay, so now at a given temperature, they all have the same average kinetic energy, but the average speed depends on the masses. Okay, the mass of the particle, right? The particles with higher masses will have a lower speed, and then particles with smaller masses, the lower masses, will have a higher speed, and so forth. Now they're talking about the highest average speed. That means we are looking for the lightest particles. The lightest particle should be, to do this, we need to know how to determine the relative masses of the particle. So let's do that over here. So nitrogen is the relative atomic number of nitrogen is 14. You have 2 of them here. Therefore, nitrogen is N2 is 28. And then argon is 40. Okay, so if you go to argon here, you see that number under argon is 39.95. It's closer to 40. And then when it comes to oxygen, relative atomic mass of oxygen is 16. You have 2 of them. Therefore, it should be 32. Okay, so nitrogen is the lightest particle out of all of these. Therefore, it should be moving the fastest, with the fastest or highest average speed. Okay, therefore, the correct option is option B. Okay, rank the average potential energy of these substances at minus 165 degrees and 1.5 bar. Okay, so minus 165 and minus, okay, 1.5 bar is over here. Okay, now all of these are in the gas phase. Okay, so if that is the case, All right, this is not the ideal case, but anyway, so even though they're in the gas phase, if they are, if the potential energy depends on the strength of interactions. Okay, so oxygen has the lowest vapor pressure at any given temperature, meaning it's going to have the strongest attractive interactions between the particles, meaning lowest potential energy. And then on the other hand, nitrogen has the highest vapor pressure at any given temperature, meaning it has the weakest attractive interactions between the particles, meaning the highest potential energy. So based on that, I would select option D. Okay, now if the question said something about considering the ideal gas behavior when they're acting as gases, then they should all have the same potential energy. But in this case, we need to go with the strong strength of attractive interactions because they are interacting. All right. Question 6. Starting at minus 165 degrees Celsius temperature, which substance needs to be cooled the least to condense and why? And to do this, I feel like I want to, use a fresh diagram of this if I can. Okay, so we are starting at minus 165 degrees Celsius. Okay, so let's assume that we are at 1.5 bar. Okay, and then which substance needs to be cooled the least? So if you are cooling, you're decreasing the temperature. So if you start decreasing the temperature, you see that you are going to reach the vapor pressure curve or liquid gas boundary of oxygen first. Okay, meaning oxygen is going to condense first. Okay, so we need to cool the oxygen sample the least to condense, go from gas to a liquid. Okay, and then argon, and then we need to cool a lot to reach to condense nitrogen a lot. Okay, so therefore I'm gonna pick oxygen. Okay, because attractive interactions between the particles are stronger, so it should be option A. Okay, which statement best explains why pressure increases when number of particles and increases while volume and temperature are constant? Okay, so when you increase the number of particles in a container, you're going to have more collisions with the walls of the container. Therefore, you're going to have a higher pressure. That's the idea. Okay, so the options are the particles collide more frequently with each other, the container becomes heavier, the particles collide more frequently with the walls of the container. This is inexplicable. Anyway, so it seems like option C is the most reasonable answer. Okay, so question 8. How would the kinetic energy and potential energy during the process indicated by the arrow in the... Okay, so the potential energy change during this process. Okay, you are going from X to Y. You see that we are increasing temperature. Okay, X has a temperature of minus 185, and Y is minus, I don't know, minus 175 or minus 173 or something like that. So we are increasing the temperature. Okay, if you're increasing the temperature, the kinetic energy must increase because temperature is a measure of the average kinetic energy. Okay, so any answer that says the kinetic energy decreases is incorrect. For example, C and D are incorrect. So we have boiled down our options to 2. So we have 50% chance of getting this right now. Anyway, now kinetic energy increases. Okay, and then what about the potential energy? So X is above the curve of oxygen of nitrogen, meaning we are in the liquid phase. In when we are at X, in Y we are below the curve of nitrogen. We are in the gas phase when it comes to nitrogen. Therefore, liquid is becoming a gas, okay, meaning the interactions between the particles are weakening. Therefore, the potential energy must increase as well. So for that reason, we would say that both kinetic energy and potential energy increase is the correct answer of this, option B. Right? And 9, which particular representation best matches the process undergone by particles in the process indicated by the arrow x to y? So liquid is becoming a gas. So liquid, the more likely liquid is not, should be something like this. So this is a liquid. Okay, right? This is a liquid. This is a liquid. This is a gas. This is a solid. Okay, and then a liquid is becoming a gas. Therefore, option C seems to be reasonable. So we will pick option C. Question 10, which change in total energy versus temperature diagram best represents X to Y process? Okay. So during X to Y process, the temperature is increasing. Okay. Meaning we are heating the system. If we're heating the system, delta E is positive. Change in energy is positive. Therefore, these guys are out. Okay. And if we're heating the system, we should start at a lower temperature and end up at a higher temperature. Okay. And then how do we know the starting point? Well, at the starting point, the change in energy or delta E is 0. Okay. So in option A, we are starting at this point over here, which is lower temperature. But in option B, we're starting over here at a higher temperature and ending up at a lower temperature. So if you are heating, option B can never occur. Okay. Therefore, our correct answer must be option A. And another way to think about this is, so when you start heating, the temperature increases, the total energy increases. During the phase transition, the temperature remains constant, but all the energy we supply is used to convert liquid to the gas. In this case, the phase transition to gas. And then once everything is converted to gas, again, temperature increases. So here's gas. Okay, so correct option is option A. Question 11, which peg diagram best represents states? Okay, best represents the potential energy and number of configurations for states X and Y marked on the wave pressure graph above. Okay, so X is a liquid, so liquid, and Y is a gas. Liquid has strong attractive interactions, meaning lower potential energy. So potential energy wise, X is lower than Y, and number of configurations wise, Y has more number of configurations than X, because Y is a gas. Gases have more configurations than a liquid. Okay, so X is lower in potential energy and lower in number of configurations. So it seems like option B. Okay, and moving on to the last MCQ page, starting at 3 bar pressure and minus 165 degrees Celsius temperature. Which of the following changes can be used to separate oxygen from a mixture of oxygen and nitrogen? Okay, so you're starting at 3 bar, which is over here, and minus 65. So I would say we are at this point over here. Okay, if you want to separate oxygen, which is this oxygen, and this is nitrogen, this is the mixture, then we need to be in this region. Okay, so we can either decrease the temperature or increase the pressure, or decrease the temperature and increase the pressure. So these are our options. So let's say now increasing the temperature to minus 150 degrees Celsius, no. If it increases the temperature, we cannot reach this region. So that is at the 3 bar, same pressure, right? So it's out. 1 is not an option. Decreasing the temperature to minus 190. If we decrease the temperature to minus 190 at 3 bar, you're gonna reach here. That's too much. Okay. So if we do that, both of them are in the liquid phase. So therefore, that is out as well. And then increasing the pressure to 6 bar, while holding the temperature constant. So it is like this. It is like this one over here. So you will be in this region like that. So that will put oxygen in the liquid phase and nitrogen will be in the gas phase. So therefore that will achieve the separation. So only 3 is correct, and that should be option A. All right, solubility of nitrogen in water is depicted by the peg diagram to the right. Okay. Under what conditions the dissolved state is favored? So if you want to favor the dissolved state, you need to have a higher temperature. Why is that? Because high temperatures favor the state with high potential energy. D has a higher potential energy. You need to have a higher pressure. Why? Higher pressures favor the state with lower number of configurations. D has a lower number of configurations. Okay, so higher pressures and higher temperatures. That would be option C, under high temperatures and high pressures. All right, question 14. The Titan's atmosphere contains trace amounts of this chemical compound with a relative mass close to 28 AMU. What is the most likely identity of this substance? So we're talking about a chemical compound. Okay, so these two are out, and CH4 has a relative mass of 16 plus 4. Oh, sorry, I take that back. It's 12 plus 4. Okay, 12 plus 4, because carbon is 12, hydrogen is 1, you have 4 of them, therefore this should be 16. And then CO, carbon is 12, oxygen is 16, 16 plus 12 is 28. So correct answer must be option D. Okay, question 15. Ethane is another gas found in Titan's surface. What is the mass of 3 moles of ethane? So relative mass of C2H6 is 2 times 12 plus 6 times 1, which is 30. Okay, and if this is the relative mass, if you take the gram amount of that, that will be the mass of 1 mole. Okay, so if 1 mole is 30 gram, then 3 moles must be 3 times that, 90 grams. Okay, another way to do this is we know the number of moles is mass divided by the molar mass. Okay, therefore the mass is number of moles times the molar mass. Number of moles is 3 moles. The molar mass is 30 grams per mole. Okay, so moles cancel out. 3 times 30 is 90. So option D. Question 16, the last question. Imagine that we have a pair of 50-liter containers containing argon, container A, and nitrogen, container B, at 360 Kelvin. The pressure in each container is the same. Okay, so same volume, same temperature, and same pressure. Assuming ideal behavior, which container has a larger number of molecules? Okay, so we are at the same pressure, same volume, okay, and then N, same constant, same temperature. Okay, in both cases. Okay, so this is container A, container B. Okay, they have the same pressure, volume, and KBT. Okay, so because they all are same, all right, they should both have the same number of particles. Okay, or same number of molecules, if you want to say. So therefore, both containers have the same number of particles, should be the correct answer. All right, so that is that. Just to complete this, I want to make sure that I bubble in the answers in the pre-response page, or the last page. Let's do that. You don't have to stay for that. Okay, I'm going to stop right here.